In this presentations we are going to discuss about the directory implementations. So in this directory implementations done by linear and the hash table. So in this linear list of file names with pointers to the data blocks. So it's in simple to program. So and the time consumptions to execute in this linear search time. So could keep ordered alphabetically via linked list or user B plus tree. So in this hash table, linear list with the hash data structures. So here decreases the directory search time. So the collisions is in situations where two file names hashes to the same locations. Only good if entries are fixed size or use chained overflow method. So it's allocating methods or it's in contiguous allocations. And allocations methods refer to how the disk blocks are allocated for the files. So in this contiguous allocations, each file occupies a set of contiguous blocks. So the best performance in the most cases, it's in simple, only starting locations and the length are required. The problems include the finding a space or a file, knowing file size, external fragmentations need for the compactions of file and the compactions of line or online. So in this contiguous allocations, mapping from the logical to physical, the block to be accessed q plus the starting address, the displacement into a block is r. So that is in the target address. So it is displacement value, it is a target address, so that can be copied from the starting address plus q to the displacement. The extent based systems, so many newer file systems uses a modified contiguous allocation scheme, that is an extent based file systems. So it allocated disk blocks in extents. So an extents is a contiguous blocks of disk, but it extends our allocations for a file allocations. The file consists of one or more extensions. And the linked allocations, each file is a linked list of the blocks. So the file ends at a nil pointers. No external fragmentations. Each block contains a pointer to the next block. 1. Compactions, external fragmentations. Free space management systems called when new blocks needed. Improve efficiency by clustering blocks into groups but increases internal fragmentations. The reliability can be a problem, and locating a block can take many IOs and disk schemes. In this fact, there is a file allocations tables is essential, that is in variations. The beginning of the volume, the has table indexed by a block number, much like a linked list but faster on disk and catchable. So new block allocation simple. So in this linked allocation, each file is a linked list of the disk blocks. Blocks may be scratched anywhere on the disk, but it can be linked by its address. The block to be accessed is the qth block in the linked chain of blocks representing the files. So the displacement into the blocks is an r plus 1. So where it is to be stored in this r plus 1. So the file allocations table is also have the starting address, then the displacement address. So here that can be copied from the start disk to that represented displacement. Allocation method is an index. So next allocate the index allocation. So each file has its own index blocks of the pointers to its data blocks. That's index values is essential to view that file. So each index value is listed. So using this index value, the file can be accessed. So here the many files are available. Here the directory has the index block is a 19. So the index allocations need index table, random access, then the dynamic access without external fragmentations but have overhead of index block. So the mapping is done here easily, so that mapping from logical to physical in a file of maximum size of 256 kilobytes and a block size of 512 bytes. We need only one blocks for an index table. So the displacement calculations is an essential. So it have the two level of index. So that index table is described by the two levels. That is an outer index and inner. That is an index table. This is an index value descriptions. Okay. So the logical is first one, then the outer index and index table is described, then the file. So this is an examples of how to the data are filed in this Unix system. And the performance, it is an best method, depends on the file access type. So in this contiguous, great for a sequential and random. So the linked, good for a sequential, not random. The declare access type at creations, select either contiguous or linked. So in this indexed, more complex, it is a simple block access, could require two index tables, read, then data blocks are read. So clustering can help improve throughput, reduce CPU overhead. So the contiguous is an efficient, but compared to that linked, it is an faster. So adding the instructions to the execution path to save one disk input output is a responsible. So it has multiple descriptions and drives. So for that examples of the disk size and that accessing speed and accessing time. So in this free space management, it maintains a free space list to track available blocks and the clusters. So here the blocks are indexed or accessed by using the bit vector or the bitmap. So the bitmap requires extra space. So the block size is 4 kilobytes. So the disk size is to power the 40 bytes. So if the where the number of bit map is required is 2 power 28 bits. So easy to get contiguous file. Linked free space list on the disk. So it is a linked list, so cannot get contiguous space easily. So no waste of space, no need to traverse the entire list. So the grouping and counting is performed essentially, and the space maps is, it uses a SFS and considers the metadata IO on the very large file systems. File data structures like a bitmaps couldn't fit in memory. Thousands of IOs divides the device divides the device space into a meta slab units and manage the meta slabs. So where the each meta slabs has associated with the space map, so uses the counting algorithms. So at the but records to a log files rather than the file system. So metaslab activity, it's a load space map into the memory in balanced tree structures indexed by the offset. So in this efficiency and performance compared to that, disk allocations and directory algorithms is an depending factors and the type of data kept in the file directory entry and pre-allocations or as a needed allocations of the metadata structures and fixed size varying size data structures. So the performance is also based on the keeping of data and the metadata close together. So it is an actually but the buffer hatch synchronizations, asynchronizations, that's an accessing process, and the free behind and read ahead. So this optimization sequential access is also decide the performance. So in this page catching is a virtual memory accessing technique. So the page catches the page rather than the disk blocks using a virtual memory techniques and the address. So in this memory mapped, the IO uses a page catch rotate. So here the routines IO through the file systems uses the buffer cache. So that can be explained. The file systems has a buffer cache. Okay. So in this page cache is a one part of the movement of the data for the memory going to that storage. So directly IO request for the read and write operations. So the file systems are holding content are temporarily stored in the buffer cache. So the data can be read and write directly from the buffer cache. At the same time, it can be loaded into the memory by using the page cache. So the unified buffer cache. The unified buffer cache uses the same page cache to catch both memory mapped page and the ordinary file systems IO to avoid the double caching. So when we used a file systems with the buffer cache, it can communicate with the IO input output request for the read and write operations and the memory. So the recovery systems has the consistency checking and backup maintaining and recover the lost files or the disk by the restoring data from the backup. So in this log structures file systems is a file systems record each metadata update to the file systems as a transactions. All the transactions are written to a log. So the transactions in the log are asynchronously written to the file system structures. If the file crashes, all remaining transactions in the log must still be performed. So the faster recovery from the crash removes changes of the inconsistency of metadata. So it is essential and that can be implemented in the NFS system. Thank you.